Thanks for coming all the way over here. I know it was a long journey to London. We wanted to give you a quick brief before we send you unattended into the tunnels underneath the city. We had a bad last run-in with the cops, so we won't be able to join you on this mission.
Don't forget, we're paying you big time. Don't fuck up like the last guy.
What you're gonna need to find is this. It has to be this specific medallion, so pay attention. The medallion you are being sent to receive is said to be the key to the hidden vault deep inside the Temple of Horus at the Egyptian pyramids. Don't go digging amongst the other treasures down there. You'll find yourself in some trouble if you take too long to get out. The catacombs were designed to keep out unwanted visitors and protect the precious items they hid inside.
Not to scare you, but no one has ever ventured this far inside successfully and lived to tell about it. I'm not sure what you might see when you're down there, but don't let the walls play tricks on you. Make it out in a timely fashion, because staying down there too long can cause you to go crazy.
Are you ready?
To make the animation cutscene that runs at the beginning of gameplay, I started by building the scene, combining multiple assets and textures from Fab. For some assets, I edited the mesh and added new textures. The lighting gives dimension to the room, bringing attention to the characters while also remaining cohesive with the map. We each designed one of the metahumans, making sure they had different characteristics to make a realistic expedition group. Zane's body animation was a motion capture I filmed with a Rococo suit. I baked him to a control rig and fixed up the animation by adjusting the rig and setting keys. For his face, I used the LiveLink Face app and processed the footage in Unreal to create an animation compatible with metahumans. I also baked that to a control rig to adjust the animation. Both of the women, Laura and Max, were animated using Mixamo, and their face animations and voices were also created using processed footage from the app. They're both baked to control rigs on the face and body. For the user interface, I started out in Photoshop, creating the menu elements from scratch. Once I was done with that, I was able to create a widget blueprint and import the assets. I actually had to make 6 button images since the start and the quit each have an image for when it's regular, hovered over, and then clicked on. In the widget blueprint nodes, I coded the quit button to exit the game and the begin button to trigger you to the animation level, starting the game. There are actually triggers coded in each level to take you to the next. To actually put the widget menu into the game instead of attached to the viewport, I had to create a widget actor class to drop it in the map.
The look and atmosphere of the map and game were inspired by the catacombs and their maze-like orientation. We wanted to use various textures and assets to put our own spin on things and create an underground dungeon experience. The majority of the assets were pulled from Fab, and the layout of the walls were made in Blender, where we created a confusing yet winnable layout for the second level. We wanted to change the controls of the VR pawn for a more realistic player experience. This involved changing the movement method from teleportation to free locomotion. To increase immersivity of the gameplay, we thought a joystick control would be beneficial to making the player feel like they were actually inside the game. We kept the same idea when changing the rotation to a free rotation instead of a clicking mechanism. This allowed the player to more easily turn around corners and explore the map in a natural way. We also included a sprint mechanic where the player can hold the joystick down to run faster, allowing them to outrun enemies in the second map. I created a realistic working door for some interaction between elements in the first level. The door works with a lock and key, meaning the player must find the correct key and insert it into the keyhole located behind the lock asset. The door cannot be opened prior to inserting the key. It works realistically, meaning that if the key is removed while the door is open, the door can still swing around until it is shut. If the player then tries to open the door while the key is not inside the lock, it is impossible to grab. The key is also associated with the sound, indicating to the player the door is open and movable. To keep it even more realistic, I made it so that the door can only be grabbed and manipulated from the handle. The key also follows a spline on the keyhole blueprint, meaning it clicks and follows a line to properly be fully connected into the lock. For the enemy, we created an AI movement system, meaning the enemy freely walks around on its own inside of our navigation mesh. It relocates itself every few seconds, patrolling around the map looking for a player. When the enemy locates the player in its line of sight, it transitions from a walk to a run and actually speeds up to catch the player. It will chase said player until they are out of its line of sight for at least 2 seconds, and then will revert back to patrolling. We chose fitting animations for when the enemy is walking versus running to increase player fear or interaction with the enemy. We also choose to use sound localization so the player can be aware if they are close to an enemy. There are 2 sounds, one with a larger radius that can be heard farther away, and then another that happens if you are scarily close to being killed by one. We used the capsule component we created for the enemy to trigger the player into a jump scare. We used an animation that appeared to be eating the player so that when sent to the jump scare, the enemy is right up close to the player's face. Instead of sending the player to a new level, the VR pawn view is switched to a Cinecamera actor programmed with the jump scare sequence. This sequence is coupled by discontinuing the input of both controllers, meaning the player cannot run away.